Welcome back everyone, Mr. Allen here. I'm going to go over a couple of examples here of using the sine law to solve triangles. Just want to state up front that I'm starting this with the assumption that we already know the sine law is what we should be using. So that's to say we've established this is not a right angle triangle that we're working with, and it's not a situation where we have the three sides or a side angle side question, both of which we'll use the cosine law to solve. Okay, so our first situation is we're looking for a missing side. Here I have, well, obviously this given diagram. The sine law in one of its two forms looks like this, and the key here is to remember whichever of the sine law forms I choose to use, I'm going to try to establish that the unknown value, in this case the x that I'm looking for, is going to be on top. So I prefer this form to the other form, which is that one, for this first question, because I want to have my unknown value in the first position on top so that I can, in the numerator, so that I can easily simplify the question. So now before I can do that, when I look at this, I'm looking to line up the different values here. And when I go to do this substitution, my x is my unknown. It lines up with sine 35. Because of course the width of this angle is what establishes the length of this side. As I stretch this angle wider, this side gets longer. So those are the two that go together. This 15 then, the other known value, must work with this missing angle here. And we should be able to find that missing angle if I can actually grab this by doing a fairly simple calculation here. The missing angle, of course, is 180 minus this 98 minus this 35, or 47 degrees. Once I've established the two ratios, and I guess the other thing I should mention is, notice from the start I did not label my triangle A, B, C, and D, or just A, B, and C, because I want to make sure that I can use whichever pairings of sides I want. Here I want the unknown value and the angle with which it pairs, and I want the known side and the angle with which it pairs. And I just call those A and B for the sake of having a formula here. If this triangle were labeled PQR, I could easily enough change these to P's and Q's, or I could just ignore the lettering that was there, the labeling that was there, and just use A as the side that I want to work with, and B as the side that I have. And after that, I'm pretty much close to done already. I'm going to multiply through both sides here. I have a divided by sine 35 that I don't really want, so I'm going to multiply both sides by sine 35. Of course, the sine 35's divide out on the left, and then I end up with 15 times sine 35 divided by sine 47 on the right. And that, when I punch it into a calculator, is approximately 11.8. So this missing side is about 11.8. And that works out pretty nicely with the numbers I have. If we think about, I have a 35-degree angle and a side that's about a length of 12. This angle is a little bit wider at 47, and this side is a little bit longer at 15, so that seems to make a lot of sense. The second type of question we can run into, of course, is finding a missing angle. So here's my starting point. Now again, I'm choosing the form of the sine law that is most appropriate to the question. In this case, I'm looking for an unknown angle, so I'm going to have my angles in the numerator. Now as I go to set this up, I'm looking for x, so I'm going to, I would like to start off by putting sine x in here, but because I don't have a side to go with the x, I can't use it yet. The key here is to recognize I need to have one unknown value when I fill in my values here, when I do my substitution. If I use the x and an unknown length of y, I would end up with two unknowns. So instead, I'm going to use sine A. So essentially we'll call this corner over here the A that I don't yet know. And so sine of this angle here, with respect to this side over here, is going to be the same ratio as sine of this 35 to the 18. And now again, one unknown value in my equation, I can multiply through both sides by 15. I get 15 times sine 35 divided by 18 over here. And then, of course, to find the angle, I must use the inverse. So to find the angle, use the inverse. It can be our mantra. To find the angle, use the inverse. To find the angle, use the inverse. All right, so get that in your head, and then basically I'm just going to punch that in again, calculator work, and I find an A value of approximately 28.6. I don't remember exactly what it was, 28.55 maybe. The actual value I'm looking for was this angle X. I now have the other two angles, the 35 that I was given, the 28.6 that I found, and so angle X is 180 minus those values, gives me about 116.4. And then, of course, if I were looking for this missing side, which is another possibility, I could take it that one step further and find the missing side by doing another sine law at that point.